And this comes to solid principles. Solid principles are the foundations of your thinking as an engineer. The difference between a developer and an engineer is knowing these principles and knowing how good software is built. So I'm going to give you some simple definitions of solid principles. Single responsibility. A component should do one thing and have one reason to change only. It's hard to achieve sometimes, but if you start thinking about extraction and modularity, it gets a lot easier for us to get there. And I'm going to show you some examples so you really get the sense of how it is applied to React. The second part is open-close principle, which is you should be able to extend the behavior of your components without modifying them. This is what I mean by the Lego blocks. If you build your Lego blocks in the right way and you're able to encapsulate your small UI Lego blocks, it means you can actually extend the behavior without having to worry about modifying and maintaining. And am I breaking something when if you modify the atom level components to base level components? Liskov substitution. You should be able to swap your child elements without breaking the parent. If I've got an input, I should be able, and I've made it into a custom component, right? I should be able to swap that for the actual input HTML tag, and the same inputs, the same interface should be consistent. And it allows you to swap parts of your application without breaking anything. It means that what this means for you in practice is if you've put your eggs into building with one API and then your business finds a better API they could be building with, the top level props or interface should be flexible enough and use case almost geared to that implementation, but not tied to the implementation of the API itself. I'll show you some examples and you'll see more about this when we get to it. So the next one is interface segregation. And what this means is when you're passing props in, we only want the smallest amount of props. With TypeScript, it's actually easy to do this because you can pull types out. But in JavaScript, what this basically means is if you have an interface that only needs part of a object that you're passing in, say you're passing the user object in and all you need is the display name. You should be only passing the display name, not passing in data that that component doesn't care about or rely on. And then dependency inversion. So it depends on abstractions, not concrete details. So as I said, we want to extract and we want to push the side effects to the edges and not have to worry about like this API call is very much nested inside of this component and it's really hard to change it. So here are some opportunities of how you would apply this in React. So I'm going to do this quite quickly. This is the slide for you to come back to and use the presentation and like learn these for yourself. But we're going to go through examples, so don't feel like you need to memorize these right now. But single responsibility, that you want to split big components into logic and display. It's a really easy way of doing it. As I said, extracting, fetching, and state with like state and use effect together into custom hooks, keeping that UI component pure and focused on inputs, outputs, and easy to test that. Open close, the Lego style composition works really well to extend the UI without having to change the components themselves. And you can apply higher order components to wrap components in order to pass props down without needing to share anything necessarily directly or modify your component. Liskov, ensure variant components share predictable APIs. You want to be able to swap your button you want to be able to swap your specialized button potentially for your normal button, and it should still work the same way because your interfaces and your props are consistent. Then for interface segregation, you want to pass in specific primitives. So as I said, don't pass in big objects if you can help it. Pass in just what it needs and like discard the rest. Make sure that your data flow through the application is as clean as possible. It will massively help in performance, I promise you. Because when you if you pass in a user object and something in that user object gets updated because you've updated some state in the user context, that means that component has to re-render, even though it might not depend on any of the properties inside of that object. So let's jump into some examples. So the first one, the single responsibility principle. As I said, one component, one reason to change. You'll oftentimes have huge components like this. We call it the God component because it does everything. So what it means is when your component does too much, and it can change for any reason. API, formatting, UI can change. There's a lot going on, which means you're probably going to get more re-renders than you need to. And it makes it really hard to test the individual parts because they're so tightly coupled together. And if you've got those multiple concerns tangled together, someone has to detangle them, or that component is only good for that one specific use case. So you end up creating more components, adding more complexity to your applications, which is ultimately going to hurt performance and hurt the user experience down the line. The best way to do it is to separate. Think about each piece. What is the job of this function? What is the job of this component? And extract away the how and let the component handle the what, the UI. And as I said, doing it this way makes it really easy to test and change things really easily within your application. Open close principle. So as I said, extend behavior without modifying the existing code. When you get into the trap of modifying, every time you need to add a new feature, you end up editing that component. And that risks breaking the existing functionality, especially if you don't have tests. There's an alarming amount of you that haven't written your unit tests, and that's something we will definitely be covering in a future episode of this series, where we'll walk you through exactly how to test, what the right methodologies for testing, and how to make it easy for yourself. But if you get into this trap of continuously adding features to your components and bloating them up, and it makes it really hard to test because you have to mock all of these dependencies. Whereas if you've done your extraction properly and your composability in React, you wouldn't have that problem, or you'd have a much smaller version of that problem. So if you look here, you'll see we have a base button and we have an icon button. The base button doesn't really change. All its job is to render the button. And the icon button is to render the button with an icon. So it still has one responsibility, but it's that you've reused your base component to extend with an icon. So this is a very simple example, but the bigger the component becomes beyond being a button, the more relevant and the more important it is that you do this. Liskov substitution. So you should be able to swap components without you should be able to swap the children component without breaking the parent. So when a component changes the expected interface, it means that the parent must now understand the implementation details. You can't swap it. You can't swap one component for another, and it breaks when substituted. So you see here you've got a search input, but the interface, the props, are not what you would expect to see from a standard input. And because of that, you can't actually swap this search input out for a normal input. So it breaks the substitution principle. What you want is, if you're going to have a search input and you have your input, I'm not necessarily the biggest fan of spreading props down. This is where TypeScript makes a huge difference to your type safety and making sure you're not passing the wrong things in, because you can extend the HTML input type. And that means you've got a good sense of contract between what your inputs are. But in this case, what you're doing is you're spreading the props, because every single attribute or prop that you're passing into your input tag will be the same regardless. You should be able to swap any search input and it should work as expected. And then it will look like this, where you're passing in the same values you would to the input, but the interface is the same. Pillar 4, interface segregation principle. So only pass what the opponent actually needs. And this makes a huge difference, because if you're passing in data and big objects in, it actually slows down your performance, even by 10x sometimes. The difference between in use state, for example, between using a string and a deeply nested object can be 20 milliseconds versus 120 milliseconds. So a 10x performance hit just because you're passing huge objects in to your use state hook. And it's the same thing when you're passing it down into components. You're bloating them with every bit of data that you're passing in. Might be, if you do this once, it's not going to make a difference, but do this consistently, your app will suffer. So I think that's someone joining. Anyway, user avatar. Let's look at the example. So in this case, the user avatar receives the entire user object, but it's only using the avatar ID and the username. So we're locked into the user's shape. So if the user set changes, there'll be more properties. If that expands, there'll be more reason for this component, when its props change, to re-render the whole component. We don't want it. Whereas we can actually just say what we want, what this component actually needs, and then deliberately pass it in that way. And it also adds some flexibility. Like, you don't have to manipulate the user object to be able to pass in this example, and have a guest avatar. You can just pass in exactly what you need for the image URL and the name. It makes it so much easier for your component to be the flexibility that it needs. So you don't need to create another component because your props weren't configured correctly. Dependency inversion. So depend on abstractions, not concrete details. So this is about lifting state up. It's about abstraction, and it's about thinking about how does this component, what dependencies and what coupling have I got in this component. So if we look at the first example here with user greeting, it's receiving a user ID. We have some state, but this user greeting really depends on the user effect. Like the user effect is fetching some data, and then it's setting it on the user, and it's also doing some loading. But the entire user greeting is dependent in its internal implementation details, is doing that fetching. Whereas if you actually elevated it upwards, and we were able to pull from, like, if we have this, for example, higher order component that manages the loading from the user, and we have a hook that we've extracted this fetch into its own custom hook, we're able to easily pass it down, and it reads better, it's less decoupled, and it's far easier to mock the return of user, rather than basically have it be dependent on every time we go and use that component. I see a question, 1 second. Wonderful. See you later, Jack. Thank you very much. So before I move on, why we do this is because we make it easier for our components to be tested, easier to reuse, and it's easy to change smaller components. When we've extracted and we've modularized things, we can look at that in isolation. We don't have to jump into the user greeting anytime we want to change how the fetching happens for our user. So the final exercise is you're going to apply the solid principles to a God-sized component. So you're going to have a big component in exercise 3, which is a user profile. And there are already a lot of good stuff for you guys to do, is to show me how you would extract custom hooks, how you'd think about the solid principles. I'm going to give everyone a hint. There are 4 solid principles being violated. So there are a few. And this is where thinking about the solid principle and applying it to this will be super helpful to you. So I'm going to give everyone 7 minutes again, and then I'm going to do some review. So I'm looking at this user profile, and there's a few things that immediately stand out to me. So the first thing I see is this massive user effect that has nested .then. So I see, as soon as I see this user effect and I see a set data, I think extraction. I think about pulling out a hook, and I would think about what are we fetching? How are we setting that data? And then how can I pull this out into a use user hook potentially? What are we getting from here? We're getting placeholder data, and we're setting data, which is why we never use the word data, because it's confusing. Let me have a look down here. We have a handle save function. So we're making some sort of validation. Validation is often a good thing to extract into its own function, where we're actually passing in and it's doing the logic behind the scenes. I see an alert here. Should we be using an alert? Should we be using a toast notification? That's the one thing I'd be thinking about. So I'm seeing spread operator here. So this is the big user object and we're updating the name. Fine. And we're looking at if the function is here, you should use it. You don't necessarily need that. Again, it's already saying you don't need that. So changing it to an optional chain. Format address, if this is a reusable function, definitely extract it out. I'd put this in a utils folder. Early returns are great. We love early returns. It means you don't have to evaluate all of this code. Now, when I get into the user profile, obviously there's a lot of opportunities here. Header tag, this p tag. But I'm looking at this and I'm going, this is the profile header. Could this be a reusable component? Could be. It definitely would help with abstraction. So user profile header as an example. Profile details component. I'm questioning why we need this show email. Can't it be if we have an email, then it would show? That makes a lot more sense to me. Okay, company info, that's fine. This entire thing, profile details, could be its own reusable component. And again, profile actions. I'm looking at this and going, I would love to use our reusable button component. Seeing we're doing inside of here, we're doing is set is editing. I'd be thinking about if this is setting to is editing mode, how does that affect? Could this editing whole functionality be pulled out into its own hook? Because editing could be reused across multiple parts of the code base. So I'd be looking at different parts of the code base going, is there editing functionality? Can I extract that into a reusable hook where I can just pass in a reference and that field or input becomes editable? These are the things I'm thinking about as I look at this. And I look at this post.length. You can absolutely do this. What post is not defined, maybe an optional chaining. I see this as a huge opportunity. Obviously, semantically, this could be completely different with a UL and UI. Seeing this is absolutely fine. We're doing a bit of formatting here. Does it deserve to be in here? I don't think so. Especially if we're formatting in the same way. This could be a reusable function because we're using it twice. So I see that as an opportunity. This entire post list could be its own component. I'm thinking about like, what is the structure of my profile and what are the reusable elements? Are they going to be reusable? Is a user profile going to be different from an admin profile? Is it going to be different in different types of profile? Have we got different users? Have we got different permissions? And so will I need to construct this sensibly? Will I need to construct this again?